So let us consider a set A with the elements A1, A2, A3 all the way up to AM. So here we are assuming that the set A has M elements. Then we're going to consider a second set B having the elements B1, B2, B3 all the way up to Bn. So this set is going to have n distinct elements. Now we'll try to find out the Cartesian product of two the sets A and B. So we'll consider the first element A1 and then form a coordinate pair with each of the elements of set B. So that will be A1 B1, A1 B2 all the way up to A1 Bn. Then we consider the second element, which is A2, and then form a coordinate point or an ordered pair with the elements of set B. So we have A2 B1, A2 B2 all the way up to A2 Bn. When we continue in this particular fashion, then we reach the mth element of set A, so we use it to form the ordered pair with each of the elements of set B. So we have AM B1, AM B2, and the final element will be AM Bn. So clearly we see that in this representation of A cross B, we have m rows. So there are like m rows, and each row has a distinct m rows, with each row having a total of n elements. So we can say that the total number of elements in the Cartesian product of A and B is simply the product of the number of elements in set A multiplied to the number of elements in set B. So let us do an example. So let's say we have a set A having the elements 1, 2 and 3, and a second set B having the elements x and y. So here we have number of elements in A equals to 1, 2 and 3, so there are 3 elements, and the number of elements in B equals to 2. Now the task is to find out the number of elements in the Cartesian product of A and B. So as per the formula that we have derived just now, then there should be exactly 3 times 2, which is equals to 6 distinct elements. So let us find it out. So we have A cross B, which is equals to the set containing the elements 1, 2, 3 times the set containing elements x and y. So we consider the first element in set A and then form a ordered pair with the element in set B. So we have 1x and 1y. Then we pick up the second element, which is 2, and form the ordered pair with the elements in set B. So we have 2x, 2y, and finally we have 3x and 3y. So we can count here that the number of elements in A and B are 1, 2, 3, 4, 5, 6. So there are 6 distinct elements. So this is how we can find out the number of elements in a Cartesian product. Let's do another problem. So here in this question we have 2 sets A and B, and these 2 sets have 3 elements in common. also it's given that the number of elements in set A are 5 and the number of elements in set B are 4. Now we have to find out how many elements are present in the Cartesian product of A and B and in the number of elements present in the Cartesian product of A and B intersection with the Cartesian product of B and A. Now it's given here that A and B have common elements, so that means number of elements in the intersection of A and B is equals to 3. Now also it's given the number of elements in A is equals to 5 and number of elements in B is equals to 4. So to find out the value of the number of elements in A and B, in the sense the Cartesian product of A and B, so that will be simply equals to the number of elements in A multiplied by the number of elements in B. So we have 5 times 4, which is equals to 20. So there are going to be 20 elements in the Cartesian product of A and B. Now here we have in the next part of the question, we have to find out the number of elements present in the Cartesian product of A and B intersection the Cartesian product of B and A. So here we know that the Cartesian product of A and B has got a 3-element common. As we have 3 elements common in both A and B, so the Cartesian product of A and B is going to have 3 unique coordinate pairs or ordered pairs, which is going to be same as the 3 ordered pairs in B cross A. So that means the total number of elements will be 3 times 3, which is equals to 9.